So just sharing my screen for one moment in order to introduce the next talk. Happy to have Miriam here with us as well. We actually just collaborated recently on a blog post, so I'm sure I'll mention that. And I will then pass it on to you, Miriam.
Yeah, so let me just share my screen. Yeah. Okay, sure you can see it now. Yeah.
Yeah.
Okay, so thank you for the invitation. It's a pleasure to be here today. I'm Miriam Santos. I'm the data science advocate at YData, and today I'm here precisely to showcase this collaboration and discuss a little bit with you how the data-centric paradigm is shifting our attention to achieving high-quality data, and what part does synthetic data play in that? So getting data or generating data that meets our expectations. So as I'm sure you know, data quality is indeed what makes or breaks our AI and ML applications. And one important data quality issue that we normally find in real world domains is having imbalanced data. So imbalanced data is a situation where we may find a disproportion between class or category concepts, and that leads to biased machine learning outcomes because algorithms are traditionally focused better on more represented concepts. And data augmentation is really a way to bypass this issue and can offer several benefits across different verticals such as finance, healthcare, and retail. And so you see, simply by focusing on smart data preparation, we are seeing the main mantra of data-centric AI, right? So at YData, we created the first data-centric platform, which helps data scientists to go from raw data to actionable data. This is Fabric, which is a complete workbench for data science development and is split into three major dimensions. So one is data profiling that allows data teams to quickly assess and understand the data assets, the pipelines that can enable experimentation and model training at scale. And then we have the data improvements with we offer synthetic data to unlock data sharing, enable data privacy, and overcome these issues that I've been mentioning, such as the lack of data, class or category imbalance, and even bias and the representation, sorry. So synthetic data is essentially artificially generated data that will mimic the properties and behaviors of our real data, while ensuring that the data remains private because it does not include any identifiable information. And so how can we use this in a practical use case? The first step, as always, is ensuring data quality because we need to guarantee that the generated data makes sense and meets our business expectations. And this is where GX comes in. So our friends at Great Expectations have created this awesome framework that helps us have some control over the synthesis process. And for data scientists, that is absolutely essential. And the flow is really straightforward. You can start by examining your data characteristics, define your expectation suite, and then the process becomes rather iterative. You have the synthetic data being continuously improved until it meets the expectations that you need and the quality scores that are required. Fabric and GAGs are completely interoperable, so the entire flow can be orchestrated within our pipelines. In our case, the objective was to guarantee that a specific category, which was the machine operator inspector, is represented at least 10% of the data. And of course, our initial expectations over the real data failed, but with the synthetic data augmentation, we were able to overcome this category imbalance and generate the data that we needed for our machine learning application, so our downstream objective. And overall, the look and feel of the synthetic data flow is really intuitive. You start by analyzing your main characteristics of the data. That is what gives us a better understanding of what expectations probably need to be met. And then we can start by creating our synthesizers. We can choose which features we want to include in the process. and even when and how to leverage anonymization. The detection of PII is actually automatic during the data upload into our data catalog. And we can also choose the privacy levels. So in this case, we have set it for high fidelity to mimic very realistic data and enable the conditional sampling just to focus on the occupation feature where we are going to oversample that specific category. And once we are happy with the quality metrics, we can simply generate the new synthetic samples and validate them against our expectations. So as you see, the synthetic data matches what we have, the characteristics of the original data, and we are able to successfully augment this subgroup of interest. All in all, as I've said, we have showcased this use case in our collaborative blog post. So I encourage everyone to read it and try to replicate the flow. If you want, the Fabric community is free, so you can sign up and test the platform for yourself. And of course, if you are enthusiasts like me of the data-centric AI present, we love to have you at our community. We are actually getting ready for our next Codemy session happening next week. So it's a great moment for everyone to join us. Thank you so much.
Thank you so much. I'm just gonna share the link to that blog here. Oh, you're?
Yeah, I was going to save it. Sure, thank you.
There we go. Yeah, so people can find that really easily. What questions do people have for Miriam?
Hello, Miriam. It's Josh with the questions again. In the beginning, you mentioned there's problems around like bias and fairness in your data. Yeah, talk to me more about like how YData addresses these questions. Like how do you think about, like, how do you define bias and fairness, and then how do you kind of try to approach it and solve that with YData?
Yeah. Okay, so bias can come from a lot of different sources. And I guess since we are focused on the data, our main definition of bias comes from that underrepresentation of certain specific subgroups. This can happen, of course, with sensitive information, but overall, it also compromises your machine learning models if you are looking for a specific subgroup within your data. Imagining that you have a data set for healthcare, you are trying to predict breast cancer. And the majority of your women and that data set are white. So you have a very small representation of Black women. And that leads to the model focusing on specific subgroups of that are well-represented concepts in your data. And then you have a very minority concept that is very hard to learn and may generate biased predictions, right? So one thing that YData does to overcome this is to generate more data of a specific subgroup, in this case, the Black women with breast cancer, that augments that concept representation, which allows the classifier to not be super focused on the majority concepts, but have them equally represented and be able to generate more flexible and fair, in this way, predictions. So that's overall my goal.
Yeah, and then how do I tell I have when I've achieved that? Like, is there something from YData that helps me understand this, or are we looking to like put some expectations together? Like, I don't even know. Yes, right. Like, how do you even kind of approach this in the first place?
Yeah. So you are talking about on the end point, right? How do you evaluate if your model is better or worse? Is that it?
Oh, I see. Well, yeah. So I didn't consider that. So like, I was thinking once you have the data, you evaluate the data directly to see if there was any bias built into the data. But are you saying the way you can kind of tell is you actually train a model on it and then you evaluate the results of the model?
To this point, yes, because our synthetic data metrics are evaluating three main pillars, which are fidelity, privacy, and utility. And the utility a little bit goes towards that idea. So can you generate the same outcomes from synthetic data that you would with real data? But of course, if real data is biased, then your synthetic data will eventually overcome that. But anyways, we are a data preparation platform. So the end goal of machine learning you can do in our labs and with our pipelines, but it is not our main focus to go towards that model building. That is up to the data scientists. Our goal is to provide high quality data. That's it.
Gotcha. So does Fabric actually train and deploy the models? Or is it just to generate the data?
Yeah, it's a platform focused on data centric. You can create your own models and you can deploy it, for instance, endpoints in Vertex AI and a lot of other platforms, but it's not the goal of the platform. The platform is focused on really detecting and improving your data imperfections and boost your ML through data improvement, essentially. That's on the data centric space.
Gotcha.
Not on the MLOps. Yeah.
Gotcha. Okay. Cool. Thanks.
Thank you.
As before, I'll just leave some pause to see if there's any other questions for Miriam. Okay. Yeah. Thank you so much, Miriam.
Thank you for inviting me.
Yeah, it's great to have both you and Lavanya here to showcase some use cases.